In this chapter, we're going to learn some concepts that will allow us to perform calculations in chemistry. But before we go into these concepts, we need to learn a few new terms first. There are 4 new terms that we need to learn. They are relative atomic mass, relative molecular mass, relative formula mass, as well as mole. Alright, for each term, we will look at what is it, what does the term mean, why is it being used, and how do we obtain the value for that term. So we'll start with relative atomic mass. Now, as a student, I found it very hard to memorize the definitions for these terms until I realized that the definitions can be found within the terms itself. Right? So what exactly is relative atomic mass? Relative atomic mass is the average mass. Okay, the average mass of what? Of an atom. Okay, for a specific element. And then what does a relative means? Relative means compared to. Okay, so it is the average mass of an atom compared to a reference atom. And the reference atom is your carbon-12 atom. Alright, so long time ago, scientists decided, okay, we shall compare the masses of atoms in terms of the carbon-12 atom. Alright, and they made another statement, which is this, that the carbon-12 atom has a mass of 12 units. Alright, and all the masses of all other atoms will be compared to this carbon atom. So since carbon-12 atom has a mass of 12 units, 1 unit is equivalent to 1/12 the mass of a carbon-12 atom. Okay, so relative atomic mass is the average mass of an atom of the element compared to 1/12 the mass of a carbon-12 atom. Alright, if you didn't manage to catch the definition, don't worry, it will appear in the next slide. Right, so what is it? We have already mentioned. Relative atomic mass is the average mass of an atom compared to a carbon-12 atom. Now, why do we have to compare the masses of atoms to the carbon-12 atom? Alright, so imagine now if I have a hydrogen atom, alright, in my palm. Alright, how heavy is it going to weigh? Alright, a hydrogen atom is this 1.66 times 10 to the power of 27 kilograms. That is very small. Alright, so for example, if we were to express the mass of atoms in kilograms or in grams, it's going to be highly inconvenient to do so. For example, we know that for example, a carbon-12 atom is 12 times the mass of a hydrogen atom. So what is the mass in kilograms? We can actually compute that, but we cannot compute it by heart because the number is very complicated. Alright, however, if we were to compare to the carbon-12 atom using the standard that the scientists came up with, we can straight away say that a hydrogen atom has a mass of 1 unit, a carbon atom has a mass of 12 units, a nitrogen atom has a mass of 14 units. So by using relative atomic masses, by comparing the masses of atoms to the carbon-12 atom, the values that we get are so much easier to handle. Alright, so in a simple term, we are using relative atomic masses because it is very convenient. It makes the masses very convenient to handle. So as mentioned, the relative atomic mass is the average mass of one atom of that element compared to 1/12 the mass of a carbon-12 atom. Right, the symbol for atomic mass is given by Ar. And then since it is compared to something, when you compare, for example, your weight to someone else's weight, you are 2 times as heavy. So when you compare to something, it actually doesn't have a unit. Alright, so whenever you see relative masses, they actually have no units. So now we are left with the last question, which is how do we obtain the value of relative atomic mass? Right, it's actually very easy. We can actually obtain it from the periodic table. In the periodic table, for each element, there are two numbers associated with it. The smaller number we have learned in the chapter of atomic structure, it is actually your atomic or proton number. Alright, what it tells us is the number of protons, which will tell us the number of electrons in that atom. Now the larger number is actually your relative atomic mass. Okay, so for an atom of the different element, for an atom of a particular element, we can actually obtain the relative atomic mass by looking at a larger number for that element in the periodic table. Okay, now if you scrutinize the periodic table, you will notice that chlorine has a non-integer relative atomic mass. Now why is that so? Alright, if we simply compare, since the masses of the different atoms are due to the number of protons and neutrons, so by right the masses should be a whole number. Why would it be a decimal? Right, to explain that, let me point you to this word, average mass. Okay, what does average mass of an atom of that element means? Average of what? Alright, it's the average of your isotopes. Alright, if you recall in the chapter of atomic structure, we learned that an element can exist as different isotopes. Alright, so and different isotopes have different masses. So your relative atomic mass is the average of the different isotopes. Alright, so the classic example will be that of chlorine 35 and chlorine 37. Alright, so since chlorine can exist as two isotopes, the relative atomic mass will be the average of the two. Alright, but we do not simply take 35 plus 37 and then divide by 2. Alright, why? Because chlorine 35 and chlorine 37, they exist in different percentages in nature. Alright, we call that relative abundance. Okay, so in nature, 75% of chlorine exists as chlorine 35 and 25% of chlorine 37 exists as chlorine 25% of chlorine exists as chlorine 37. Alright, so the average mass, to get the average mass, we need to multiply the mass number, right, by the relative abundance for that particular isotope. Alright, and then we simply sum up for all your isotopes, and that explains why chlorine actually has a non-integer relative atomic mass. Next, we will learn how to define the second term, which is relative molecular mass, and the same trick can be applied over here. So what is relative molecular mass? It is actually the average mass of what? Of a molecule. Alright, molecules are found in covalent compounds, so average mass of a molecule of a covalent compound, and then relative again means compared to something, compared to your carbon 12 atom. Alright, and since carbon 12 atom, the mass of a carbon 12 atom equals to 12 units, 1 unit is 1/12 the mass of a carbon 12 atom. Okay, so it's very similar to the very first term, relative atomic mass, but now this is for a molecule. Alright, and a molecule is formed in a covalent compound when a non-metal combines with another non-metal. Okay, so why is it used? For the very same reason, because the masses of molecules are very, very small. So by comparing it to the carbon 12 atom, it makes the values much easier to handle. Alright, same for relative atomic mass. Now, how do we obtain the value? This I don't think it's new. Alright, because in the very first chapter, where we learned the collection of gases, remember there was a way to predict whether a gas will sink or float. Alright, for that we need to calculate the relative mass for that molecule, for that gas. Alright, so relative molecular mass, you will see later it has a symbol of Mr. So we simply sum up the relative atomic masses of all the atoms in the molecule. Okay, So as mentioned, relative molecular mass is the average mass of one molecule of a covalent substance compared to 1/12 the mass of a carbon-12 atom. It has a symbol of Mr. Again, as long as you see the term relative, it has no units. Okay, and how do we get the value is to sum up the atomic masses of all the atoms in the molecule. Right, let's look at some very common molecules that we have encountered: water, ammonia, and methane. Alright, so how do we find the relative molecular mass? We just simply need to sum up the atomic masses of all the atoms in the molecule. So in the water molecule, we have 2 hydrogen atoms, so 1 plus 1, and then we have an oxygen atom which has a mass of 16. Alright, so it has a mass of 18. For nitrogen, for ammonia contains one atom of nitrogen and 3 atoms of hydrogen, so the relative molecular mass is 17. For methane contains an atom of carbon and 4 atoms of hydrogen, so it has a relative molecular mass of 16. Now the next term that we need to learn is relative formular mass. Alright, so by now you should guess that it's similar to the two terms that we have learned before. Alright, so we have looked at the average mass of an atom, we have looked at an average mass of a molecule in a covalent compound. Alright, so what is the thing that we have yet to look at? It's for ionic compounds. Alright, so for ionic compounds, we call the relative mass the relative formular mass. Alright, so it's actually the average mass of one formula unit of an ionic compound. Okay, again, since it's relative, so it's compared to 1/12 the mass of a carbon-12 atom. Alright, same reason why is it used, because it makes the value more convenient to handle. How do we obtain the value same as relative molecular mass? We simply add up the atomic masses for all the atoms found in the formula unit for the ionic compound. Alright, so some examples of ionic compounds would be sodium chloride, what else, magnesium oxide. Alright, and then we can have one more, which will be calcium carbonate. Alright, so how do we get the relative formula mass? You will see in the next page as well that relative formula mass has the same units as relative molecular mass. So for sodium chloride, it is 23 plus 35.5. Okay, so it is 58.5. Magnesium is 24, oxygen is 16, so we have a mass of 40. And then calcium carbonate, calcium has a mass of 40, carbon has a mass of 12, and then oxygen has a mass of 16, so you add up to 100. Okay, so when we are computing the relative formula masses, it is the classic example of how is it more convenient when we are using relative masses as compared to the real masses of the atoms. Alright, so when I computed the relative formula masses for the 3 ionic compounds, I could do it very easily. Alright, if it were to be expressed in kilograms, I wouldn't have been able to do it as easily. So as mentioned, the relative formula mass is the average mass of one formula unit of an ionic compound compared to the carbon-12 atom. Now what is one formula unit? When we write the formula of an ionic compound, for example copper 2 sulfate, calcium oxide, so whatever that we have written down is one unit, one formula unit of the ionic compound. Alright, it has the same symbol as your relative molecular mass, and for one last time, all relative masses have no units. Alright, and how do we obtain the value is to sum up the atomic masses of all the atoms in the ionic compound.